Alright, you guys, so this is factoring special cases, and basically we're just continuing on with everything we've learned. We're factoring quadratics. So there's just a couple things to remember. Perfect square trinomials, remember these are the ones that usually are written as a number minus a number squared, which means we can expand it, right, to be a minus b times a minus b, right? Or it could be written as a plus b squared, in which case it's the same binomial multiplied times itself, right? So a plus b times a plus b. And we also have the difference of squares. And again, this is when you have the same two numbers being multiplied, except that they are separated by different signs. So we have one that's positive and one that's negative. Okay, but here we're trying to factor, so we're doing the opposite again. We're starting with a quadratic, and we're trying to factor it into something like this. So looking right at this one, I can tell right off the bat, it is not the difference of squares, right? Because the difference of squares, when we multiply it out, we only get two terms. And here I have three. So I know I'm not dealing with the difference of squares here. I'm most likely dealing with a perfect square trinomial. But we're going to treat it exactly the same. So whenever we're factoring these, we have a box, right? And I know that my first one is x squared and my last one is positive 25. But what's nice about noticing a perfect square trinomial, and again I know that this is x and this is x, a perfect square trinomial is always going to have the same numbers right here and here in my diamond. So I'm going to have 25 here and I'm going to have 10 up here. So, what two numbers that are the same numbers multiply up to 25 that add up to 10? Well, that's easy. It's 5 and 5. So when you're doing the perfect square trinomial, there's not much different from the regular cases. But what we should always end up with when you're factoring a perfect square trinomial is should always end up with the same two factors. So I end up with x plus 5 and I end up with x plus 5. Okay? So this right here is our answer. Of course, since they are the same, just like I wrote it up here, you could always write it that way as well. X plus 5 squared. Okay? No big deal there. Okay, so let's take a look at example 2. Example 2, here I have two terms. So I should be noticing that I want the difference of squares. So when I get my answer, I should have the same numbers, but one positive and one negative. Okay, so again, I'm going to use my box. And if you remember before, what did we say about these two? When we have the difference of squares, these two boxes should always be opposites of each other, right? Because this one and this one, they're going to cancel each other out. So I should have a positive and a negative, or a negative and a positive, one way or the other. Okay, but if I try and use the diamond here, I'm missing that middle term. Okay, so what in the world, what number goes up here? Well, let's think about this. If I were to write this as a trinomial, I would have to write it as x squared. My negative 16 would be here, but what's my number here? Well, it's 0x, okay? Because 0 times any number is just 0, right? So that's why it cancels out. Remember, these are opposites of each other. So my coefficient is 0. So when I do my diamond, I know that this number should be a 0. So I need to be thinking of two numbers that multiply to negative 16 that add up to 0. And the only way I'm going to get that is if I have a negative and a positive, and they're the same exact number, 4 and 4. Okay? So negative 4x here, positive 4x there, and my two numbers should be opposites of each other. So let's make sure. X times what gives me positive 4x? That would be positive 4, right? And positive 4 times what gives me negative 16? Well, that's negative 4. And just to make double check, negative 4 times x gives me negative 4x. That's right. And we already did that multiplication there. So we have x plus 4, x minus 4. And sure enough, that looks just like the difference of squares. Sorry. We have x and x. We have 4 and 4, but one's positive and one's negative. Okay. So these are the basic examples, but of course I'm going to give you a little bit harder ones. I'm going to try and combine some things since this is such an easy lesson. We're going to look at stuff like this. So probably haven't had too many of these where there's a number in front, but what I have to remember is that when I factor, the first thing I want to be looking for, or whenever I have a number out in front of my first term, is that I want to try and see if that is a common factor. Remember, we did common factors when we just had two terms and we pulled one number out. So that's exactly what I'm going to do first, is I'm going to try and look at these numbers. I see 3, I see 12, and I see 12. Well, I know that all of these divide by 3, right? And if I divide by 3, or I pull it out as a factor, I'm dividing all of these numbers by 3. So 3x squared divided by 3 is x squared. Negative 12x divided by 3 is negative 4x. And positive 12 divided by 3 is positive 4. Okay? So what I've done is I've pulled out a common factor. But now when I look at this, I need to still say, oh, I still have a quadratic. I still want to try and factor this to make sure that it doesn't factor as well. So I'm going to forget about that 3 for a minute, and I'm just going to do my normal thing, which is use my box. And again, this is my first term. I don't care about the 3 anymore. I'm just looking inside the parentheses. And inside the parentheses, I see this should be x squared. Okay? So this is x squared. This is x out here. This is x out here. This should be positive 4, right? So use my diamond. I have positive 4 here, negative 4 up there. Multiplies up to positive 4, adds up to negative 4. That's going to be a negative 2 and a negative 2, right? So negative 2x, negative 2x. I know this should be a negative 2, and this should be a negative 2. So I can tell that this factors, but now when I write my answer, I need to remember that I factored out that 3. So this 3 is always going to be part of your answer. Even though you pulled it out, it's still part of the answer. So oops, I started writing the other one. So this should be 3 times x minus 2, and in this case I can write it squared, right? Because this is a perfect squared trinomial. So this right here would be my answer. And if you want to, you can write it as 3 times x minus 2 times x minus 2. Okay? So again, let's take a look at example 4. Here I have 5x squared and I have negative 45. I see that this number right here, I don't like a number in front of my first term, my squared term. So what I'm going to do is I'm going to try and factor it out. And they both divide by 5. So 5x squared divided by 5 is just x squared, and negative 45 divided by 5, that's negative 9, right? And what I should notice here is I have two terms, and this is the difference of squares. So again, I can factor this. So go back to my box. I have x squared, I have negative 9. I know this should be x and this should be x. And if you need to use the diamond, you can, but I know that if these numbers are going to be the same, these two numbers are going to be the same, and they multiply up to 9, the only possible is they're going to be opposites of each other. So one's going to be positive and one's going to be negative, but they should both be 3's. And just to check my work, I know that this should be a 0, positive 3, and negative 3. So when I fill this in, I have, since I put the positive down here, 3 times x is positive 3x, and negative 3 times x is negative 3x. These two cancel each other out. I'm just left with these two terms. So my final answer is, and again I can't forget that 5 times x minus 3 times x plus 3, because my answer is right here on the outside. Okay. So these problems start getting a little bit more difficult, but again, whenever you have a number out in front of your squared term, you always want to try and factor that number out first, because it makes your life so much easier, because then you can just get back to a basic one that we know how to do, and everything else falls in line. Okay, so this has been Factoring Special Cases. Remember your question, because these problems are going to get harder, so I want to make sure we understand this as well as we possibly can.